So welcome back to lecture 3, which I didn't complete. So in lecture 3, I was looking at the last bit, which was talking about the mirror nuclei, which I'm going to look at. Then I'll give a summary of what we covered in lecture 3. So under mirror nuclei, when we talk of mirror nuclei, we are talking about protons and neutron number interchanged. So they normally become interchangeable. And when we'll be looking at them, the key here is that the proton will be represented by the green color ball, while the neutron will be represented by the red color ball. Now, when you look at these two atoms here, they are such that the number of protons in the first one is equal to the number of neutrons in the second atom. As you can see here, in the first one, we have 2 protons, which are green in color, whose number is equivalent to the neutrons, the 2 neutrons which are in the second atom. At the same time, when you look at the number of neutrons in the first atom, which is red, is 1 here, which is equal to the number of protons in the second atom, which is also 1. So in that case, we can therefore say that the number of protons in one is equal to the number of neutrons in the other. Therefore, we refer to such atoms as mirror nuclei, having their mirror nuclei. One is a reflection of the other. So mirror nuclei, they normally have very similar binding energies, even though they have got different physical and also chemical properties. Example being beryllium, which has a mass number of 7 and atomic number of 4. So when you get the new number of neutrons, you'll take 7 minus 4, which you get to be 3. At the same time, lithium has got a mass number of 7 and atomic number of 3, of which when you subtract 3 from 7, you get 4. Now, when you compare the number of neutrons for lithium, you'll find it to be equal to the number of protons, which is the atomic number of beryllium, which is also 4. At the same time, we will also find out that the number of protons in lithium, which are 3, is equal to the number of neutrons in beryllium, which is also 3. So therefore, we refer to such atoms as mirror nuclei. In summary, we can therefore say that isotopes are atoms of the same elements which have got same atomic number but different mass number, which is normally being brought about by different number of neutrons. Okay, so we have same mass. We have got same atomic number but different mass number. Now we look at isobars. These are atoms which have got same mass number but different atomic number. At the same time, we have the isotones, which are atoms of different elements with the same number of neutrons, of course. Examples are as shown here. For isotopes, we can talk of hydrogen 1, hydrogen 2, and hydrogen 3, which have got different mass number, but you find that the atomic number is 1 all through. The mass number keeps on changing from 1 to 3. Then at the same time, we can also talk over the tritium, that is hydrogen 3, and also helium 3. So they have got the same mass number, therefore they are referred to as isobars, which you can see they have got different number of protons, which is the atomic number 3. Same with carbon and nitrogen, they have got the same mass number but different atomic number. Isotones, on the other hand, you can see here we have 14 minus 6, which is 8, 15 minus 7, which is also 8, 16 minus 8, which is 8. So it means that they have the same number of neutrons, that is carbon, nitrogen, and oxygen. So that's marked the end of our lecture of today. Otherwise, thank you so much for attending the lecture. Until now, I've come to